started on my laptop screen, ready for the Python scene. All those lines of text so clean, let's code and chase that dream. Python world, here we go. Write the script, let it flow.
In this video, we're going to be talking about branching and the if statement. And this is where things are really going to start getting interesting in our code, as we can start making decisions. We're going to get started by talking about the if statement, the else statement, and a few other things. So far in the course, everything has been very sequential. We do this instruction, then that instruction, then that, in the order. There hasn't really been any branches or different paths to go in your code. But what if we wanted to make a program like this? And this is a flowchart for an algorithm that calculates the cost of a car rental, where the cost is equal to 15 cents per kilometer, but we only want to allow users to rent who are 18 years old or older. If they're under 18, then we're going to tell them no. But if they are older than 18, then we want to continue on with the program and start asking them for how many miles they're going to drive. So we'll trace through this flowchart and see how this program should work. And then as we get a little bit later in the video, we'll actually program it in Python. So we're going to start at the start node. That's where the program begins. And the first thing we're going to ask the user for input. So let's say the user inputs 19. This is equal to their age. So now we have to make a decision. So are they 18 or over? And this is where our branch is going to occur. So in this case, they input 19, so they are 18 or over. So the answer is yes. So we're going to go down this path. And then we're going to ask them for estimated mileage in kilometers. Let's say the user puts in 1,000. Then we're going to calculate the cost, which is equal to 15 cents per kilometer. In this case, that'd be $150. And then we're going to output the cost to the user. So that might be something like the cost of your rental is $150. And then finally, we reach the end of the program and it stops. Let's see what happens if we put in a different value for age. So we start the program again. We ask the user for their age. Let's say they input 15. We make a decision. Are they older than 18 or 18 and older? In this case, it's no. 15 is less than 18. So we go down this other path, and this is where we're going to output to the user, you're too young to rent a car. And then the program finishes. So the important thing here to note is there's two different branches. We make a choice, and then based on that choice, we decide, are we going to go and tell them, no, you're too young, or are we going to go and actually calculate the cost of the car rental? And these decisions always have to be Boolean, meaning true or false. So these decisions always have to result in like a positive, a yes, true, or a negative, like false, no. So to get us started on this path to figure out how to add branches to our code, we need to learn a bit about the if statement. In Python, we can create a branch in our code by using an if statement. And this if statement takes a Boolean expression and only executes code contained in that statement if the expression evaluates to true. So it allows us to create a block of code that's only executed if some condition is equal to true. So let's take a look at the syntax. The syntax is going to be something like this. If some Boolean condition, then if that's true, we're going to execute the body of this if statement. So what this might look like in actual Python code would be something like this. If age is greater than or equal to 18, that's our Boolean expression. That's going to evaluate to either a true or a false value, depending on what age is. If that expression is true, then we're going to print out to the console, print adult. Now, one thing that's very important here is that indent, that space. And this indentation is critically important in Python. In some other languages, they'll let you get away with not indenting your code because they have some other way of denoting code blocks, for example, using brackets or something. That's not the case in Python. Python knows that code is inside an if statement, if that code is to be run, if that if statement is true, by if it's indented. And this indentation can be spaces or tabs, but the PEP 8 style guide has some comments on what you should do. Remember, these style guides don't mean that your code won't work if you don't follow them. They're sort of best practices. And the best practices are that spaces are preferred indentation method. But don't worry if you're like me and you like using the tab key to indent. If you're using an IDE like PyCharm, it will actually convert that tab into 4 spaces for you. And that is the number of spaces the PEP 8 style guide says to use. It says to use 4 spaces per indentation level. So if you want to say something's in an if statement, you have to make sure you indent it with 4 spaces, or you can just hit the tab key in PyCharm and it will add 4 spaces for you. An important note here is Python disallows mixing tabs and spaces for indentation. That won't be a big problem for us since we're using PyCharm and it handles that for us. But if you're using some other editor or you're just like editing it right in Notepad on your computer, make sure that you're not mixing tabs and spaces, as that might cause some errors. Another important thing to note is if statements can contain 1 or more lines of code. In that last example, we only saw 1 line of code, but they can contain any number. There isn't really a limit on it. So we could have multiple lines of code run if that condition is true. Also, it's important to understand what happens after an if statement is done. Whether the if statement is true and it runs those lines of code inside of it, or if it's false and it doesn't run them, execution resumes after the if statement. So after those indentations, it's going to resume there. Let's look at an example to get a better idea. So this is a very simple program. We can see the output here. You input a number, and it's going to tell you if that number is even. If it is even, then it multiplies it by 2 and outputs the result. If the number is odd, it just outputs the same number. So let's trace through and see exactly how this program works, starting at the first line. So the first line here is simply asking the user for a number. It would look something like this. So let's say the user inputs 16. We're using the int function to cast that into an integer value, so they can't put in like a floating point value. It has to be an integer. And then we store that in the variable num. So on the side here, I have num16 written, so we'll keep track of that. The next line of code is more interesting. We have an if statement, but the conditional value here is a little bit different. If you recall, that % symbol is the modulo operator. And this, as a simple way to see it, is that it finds the remainder. So we're saying num divided by 2, what is the remainder of that? So if we were to divide 16 by 2, how much remainder would there be? And then we're comparing that remainder, and we're asking, is that remainder equal to 0? So in this case, num modulo 2 means that we are going to look up the value of num. It's going to be 16. 16 modulo 2, it divides evenly, so that means there is no remainder. In this case, we'll then check, is 0 equal to 0? It is. So the result of that if statement's condition is true. If an if statement's condition has a true value, it means we enter the code block and start running that code. So the code block would be the lines that are indented. So we start the first line, we print out your number is even, and we can see that in the output now. Then we're going to multiply the value of num by 2 and store that back in num. So it's now updated to 32. And we're going to print out I multiplied it by 2, and we can see that updated now. And then finally, when we get to the end of the code block in an if statement, we resume after that if statement. So in this case, we continue on to the line, print your number is, and then we're using the string function to convert that to a string so we can add it to that string. We could also just say your number is, comma, num, that would work too. And we can see that the output was your number is 24. So that was pretty straightforward, but what happens if we have an odd number? So we're going to start, and this time the user inputs 17. So we input 17 into num, and we assign it there. Next, we do num modulo 2 equals 0. So let's break this down. So num modulo 2, in that case, it's going to be equal to 17, the value of num. So 17 modulo 2. So if we divided 17 by 2, there would be a remainder of 1. So in this case, 1 equals 0. That's our equals operator. And that's going to return false. 1 is not equal to 0. So that means the condition in this if statement is false. When the condition of an if statement is false, it means we don't enter that code block. We resume execution right after that code block. So here's the code block, and execution would resume down here. So in this case, we don't run any of those lines of code. And we jump right down here to print, and we output your number is, and then 17. And you can see that now in the little output console. So that was a pretty straightforward example. The only trick there was the modulo. And one thing I should mention is the modulo, when we do modulo 2, is a great way to check if a number is odd or even. And you'll see this coming up a lot in programming. Because if we divide anything by 2 and there's a remainder, that means it's odd. If we divide anything by 2 and there's no remainder, that means that it's even. So this is a way for us to check if a number is odd or even quite easily. Okay, let's look at a more complex example and one that's a little closer to real life. So in this example, we're trying to input a cost of a purchase and then calculate the total cost. And we have two things to consider. The first is a 13% sales tax that's applied no matter what. And the other thing is a 10% discount. But we only want to apply the 10% discount if the purchase is over 100. So the user is going to put in the cost of their purchase. If it's over 100, we'll apply a 10% discount, and then we'll add the sales tax. If the cost is under 100, that means we only apply the sales tax and no discount. So here we have what the solution would look like, and let's go try it out in PyCharm. Okay, we have PyCharm open, and we have the example loaded up. So let's go through this line by line and see what we're doing. So first thing we're doing is we're inputting the purchase cost, and we're going to turn that into a floating point number. So it's a floating point because it could have decimal points, which most costs do. And then we're assigning that value into the variable cost. Next, we have a section that handles the discount. So all this code is just for handling the discount. And what we're doing is we're saying if the cost is greater than 100, we know that's the case where we want to apply a discount. So we're only going to run this code here if the cost is over 100. If the cost is anything other than over 100, even equal to 100, then we jump down here. So if cost equals 100, we jump down here, we ignore this. If cost was even lower, like 99 or even 1, again, we ignore this and we jump and start here. Otherwise, if cost is over 100, we're going to run these lines of code. Discount here is simply calculating the discount. So let's break this one down. First, we have cost times 0.1. So in Python, we can't say like 10 and then the percent symbol to mean 10%. Instead, we have to represent that as a decimal number. So 0.1 would be 10%, 0.2 would be 20%, 0.55 would be 55%. So we're multiplying it cost by that to figure out the amount of the discount. And now we're using the round function. We saw the round function in an earlier video, but what it does is it rounds whatever the result of this is, or whatever the value of this is, into a number that has this many decimal points. So in this case, we're rounding the result of this math, and we are computing the cost, or the discount rather, to 2 decimal points, and then we're storing that whole result back in discount. So we have the discount now stored in the discount variable. So for example, if this was 1,000, then it would calculate 1,000 times 0.1, which would give us 100, and then it would round it to 2 decimal points and store that in discount. On the next line here, we actually apply the discount. So remember, we're using the minus equals operator. So what this means is figure out the cost, or what's currently stored in cost, then subtract discount from it, and then store the result back in cost. So effectively, we subtract discount from cost. So if we input 1,000, discount would be 100, and we would subtract 100 from cost, and cost would now be equal to 900. Then we're going to also print out the amount of the discount applied. So it'll say a discount of whatever the discount value is, and then applied. So remember, we can't add a integer or a float directly to a string, so we're converting it to string here. We could also use commas to give it as different values to print, and print would put in a space between them by default. There's multiple ways to do the same thing in Python. Now we're going to add the sales tax. And note that this is outside of the if statement. So this is not indented to the same level. So only these lines were in the if statement. So everything here and down are going to be done no matter what. So even if the cost was less than 100, we're still going to add sales tax. If it is greater than 100, we're still going to add sales tax. So whatever after this if, we resume here, regardless of what happened. So now we're going to calculate the sales tax, and this is done exactly like we did for cost, or the discount, except we are multiplying it by 0.13 for 13%. We're rounding that result to 2 decimal points, and saving that floating point number in sales tax. Then here we are doing a print, so we're going to output sales tax of, and then whatever the sales tax amount was, and then we add the sales tax to the cost. So discount we subtract, sales tax we add, and then we finally output the final value. So let's add some breaking points. Start right there, and let's debug this. Okay, so here we have the debugging interface. We've stopped right here. Let's step over this. Okay, so it's asking us for the cost. In this case, let's say 1,000, so I'll apply a discount. So now we're at if cost is greater than 100. Right now, cost is equal to 1,000. It's a floating point value since we converted it to float. Since it is greater than, we should now enter this if statement. So we're applying the discount. And we can see discount was calculated to be 100. Now we're subtracting the discount from cost. So you can see cost has changed to 900. And now we're going to print out the discount to the console. So if we looked in the console, we can see discount of 100 applied. Now we're calculating the sales tax. So after this line is executed, we can see that sales tax equals 117. So that would be the value of cost after the discount times by 13%, or 0.13, rounded to 2 digits. And then we're going to output the cost, or the sales tax, rather, to the console. We can see that in the console now, sales tax of 117. And now we're actually going to add the sales tax. So we'll watch this value of cost. When we run this line, we can see it's updated to the final cost. Then the final line is going to be printing out the value. And there it is, 1,017. So that was fairly straightforward. Let's try it again, though, but with a different value that's under 100. Okay, we just ran it again. And right now we are at the first line. Step over that, and we will input a cost, this time $50. Okay, let's take a look in here. So cost equals 50, 50 greater than 100, that's going to evaluate to false, which means instead of going into the if statement this time we're going to jump right down here. Let's see that. So you can see we skipped all this because it was false, and now we are calculating sales tax. Which we're going to do, sales tax is $6.50. We're going to print that out, and we're going to add that to our cost. So now we have 56.5 as our total, and then we'll output the total to the console. So your total is 56.5. So you can see when the statement is true, we go into the if, otherwise we just skip it. Okay, back to the slides. Okay, we are back to the slides. And here's another example of the output. In this case, just what we tried, putting in 50. But there is an interesting case here. So in this case, we put in a purchase cost of 112.32. The discount's what we'd expect. The sales tax is what we'd expect. But instead of getting 114.23, we got 114.229999999999, probably still going. And what this is a floating point error. So one thing we haven't mentioned yet is floating points numbers, those are the ones with decimal points, are stored in the computer's memory in such a way that they are an approximation. They're not an exact value. So this means that when we're doing math with floating point numbers, we often get little errors. And one of the ways to avoid this is to use rounding. So if we wanted to fix this in this program, what we could do is instead of just outputting cost, we could first round cost to, let's say, 2 decimal places, and that would fix this floating point error. It's something to be aware of, though, while you're using floating point numbers, because they can have a level of imprecision to them. This is why in real software that deals with real money, like your bank, they often don't actually use floating point values to store monetary values, because you don't want to be losing a few cents from every client, because that could add up quite fast. And like I said, we could fix that with round. So if we wanted to visualize what we just made in Python as a flowchart, it would look something like this. We're asking for the purchase cost. The green diamond here is where we're making the decision. Is the cost over 100? If it is, then we have that special case where we apply the discount. Otherwise, we continue on adding the sales tax. And this is nice, but how do we get multiple branches? This is just like one branch in a special case, and it just resumes exactly where we left off. How do we do either this or do that? And for that, we're going to need a else statement. And effectively, this allows us to create 2 different branches. One branch will run if the if's condition is true, and the other branch will run if that if's condition is false. So either do this if it's true, or that if it's false. Let's take a look at what that syntax would look like. So we have if condition, like we saw before, and if that condition is true, we're going to run that code block right under the if, just like we saw before. But now we have this added else statement. And this is saying that If that condition was false, then we're going to run the code under the else instead. So we're either going to run one block of code if it's true, or a different block of code if it's false. So another note about indentation. Just like we saw before, an indentation is important because it tells Python that this block of code is inside of this if statement. The same thing is true with the else. We have to indent to show Python that this block of code is inside the else statement. It lets Python know what to run if it's true and what to run if it's false. And since these are part of the same if-else construct, they should be indented to the same level. So now let's take a look at an example. If you remember from the beginning of this video, we looked at a flowchart that looks something like this. Actually, should be pretty much exactly like this. Let's say we want to now code this in Python. So we're going to switch over to PyCharm and try coding this from scratch. Okay, here we are in PyCharm, and I also have a copy of that flowchart up in the top right for us to reference. So the first thing we need to do, according to this flowchart, is to ask the user to input their age. So that should be easy enough. We've seen quite a few examples of that so far. So we're going to say age equals, and we're going to assume that their age has to be an integer value, a whole net value. They're not going to say like they're 32.5. They're just going to say 32. So we're going to use the int function to convert the input to an integer, because remember, input gives us a string by default. So we're going to use the input function, and in the input, we're going to give the prompt to the user. We can say, input your age. So that will get us the age in. And now if we look at the flowchart, the next thing is the decision. And this decision is about if they're over 18. So we can go if, and what we're checking here is their age. So we have age and age. So it's going to be age. And it says, are they 18 or over? So it's important to note here that it's inclusive of 18. So if they're 18, we should go down the yes path, or if they're any value greater than 18. So this is a greater than or equals. So we use the greater than or equals operator, and 18. So now everything indented right here under this if statement is going to be run if this is true. So it's going to be down this yes branch in the flowchart. And the next thing we have to do according to the flowchart is ask for estimated mileage in kilometers. So again, we're going to be needing some user input. And this time, I think it could be a floating point value. You could say we're going to go like 5.5 kilometers. I'm just going to call this variable km. That's where we're going to store the mileage. And we'll use float because we want to convert this into a floating point number. That's one with decimal points. We'll use input because we're getting user input. I'm going to say something like, how far will you drive in km? And I can't forget the double quotes. Strings need to be in double quotes. Or they can also be in single quotes, but we'll be consistent and keep it to double. And so we now are taking input from the user, storing that in km, which is going to be equal to the mileage. So the next part is calculate cost as 0.15 per kilometer, so 15 cents per kilometer. So we'll create a new variable called cost. That's going to store our cost. And now we want to do the calculation. That's going to be 0.15 per kilometer. So we could go 0.15 times km. And that's not bad, but there are some ways we could improve this line. So one thing we could do is that this value, it's not going to change, so it's a constant. But let's say our company changes in the future and they want to make it like 25 cents per kilometer. So instead of having someone try to hunt through this code to try to find this, we can use a constant to store that value. So at the top of my code, what I'm going to do is I'm going to make a new constant called cost per km. And in Python, like we discussed before, constants aren't anything special. They're just all uppercase variable name. And Python doesn't really enforce that the value can't change, but it is a note to other programmers to tell them that this value shouldn't change after it's been set initially. And then we can use that constant down here. And that's nice because if we wanted to update this program later, we don't have to go hunt for every spot we use that, especially if we use this in multiple places. We just can edit it up here rather than trying to look for all the 15s. So if we later wanted to make it 25 cents per kilometer, we could just update it here. Okay. Now the other issue here is this might have a floating point error, which we talked about before. So since we almost always show currency values to 2 decimal points, why don't we just round it? And the way we could do that is with the round function. This is one of those built-in functions in Python, so we don't have to import anything. And it takes the value we want to round first, which is going to be the result of this, the 0.15 times the number of kilometers, and then how many decimal places we want to round to. In this case, 2. And now we want to output the cost to the user. Say, cost of your car rental is cost. Actually, we don't really need that space there, because remember, if we give print values separated by commas, that means it's going to put, by default, a space separator between them. So it should add a space after this colon, and then give us the value of cost. But maybe we do want a $sign. So what we could do there is put a $sign, but the issue now is there'll be a space. It'll have a space between the $sign and cost. So there's a few ways we could fix that. Instead of using comma, we could do plus and then convert this to a string, something like this. And that would work fine. We'll leave it like that for now, but after we run the program, we'll see what we could do another approach. Okay, but we're not done yet, because this was only this branch to the right, the yes branch. We also need to account for the no branch. And we can't just type it down here. If we said print, you are too young to rent a car, that wouldn't work, because what would happen is if we go down the yes branch, it would then also print you're too young to rent a car after we give them the mileage. We only want to do this if it's no. So we're going to need to use that else statement. So what we're saying now is if their age is greater than or equal to 18, we're going to do this block of code. We're going to do all those calculations. But if this is false for any reason, for example, maybe they're 17, then we're going to run this block of code. And let's see if it works. So input my age. We'll start off with too young, 12. So you're too young to rent a car. And this is something you should do with your programs. You want to test all the possible branches for your code. You can't just finish now and say, oh, I put it runs, I didn't see an error, we're good to go. No, you need to test every possible branch. So we didn't test this branch here, because there could be some sort of error here that we didn't see yet. So let's run it again. This time we'll say we're 18, and that should trigger this because it's greater than equal. And we'll say we're going to drive 1,000 kilometers. And it says the cost of your car rental is $150, which makes sense to me because I think 0.15 times 1,000 should be 150. And you can see there's no space between the $sign and the 150. Let's play around with that and see the different ways we can print cost. So the other way, which we were talking about before, was just a comma. Let's see what happens when we run it with that comma. So let's say 20. Again, we'll use 1,000. And you can see there's now a space between the $sign and the 150. And that's not really what we want. So we could do like what we saw before, which was plus and then convert it to a string. We have to convert it to a string because cost would be a float and can't add a float directly to a string. The other approach we could take is instead change what the default separator value is. And we do that with the optional sep argument, sep, and we can just set that to nothing. So that means it won't add a space now, because this is the empty string. So whenever there's a separator between each value given to print, it's going to be nothing. And we run it this time. Let's do 105. I'll just say 100 kilometers this time. You can see now that that space is gone. So there's a lot of different ways we can print values in Python. It's a good idea to have a few different ones in mind because some of them are easier, some of them are harder. It depends what your preferences are. So this program seems to be working. So let's switch back to the slides. So this is a version of that program I wrote earlier. It's pretty much the same, but there might be like a slight wording difference in some of the strings or some of the variable names. But it's essentially the same. The only big difference I see here is I did the cost rounding on a separate line, whereas in that example we just ran, we did it on the same line. They're effectively the same. And this one is also using that plus string cost approach. And I also have some example outputs up here. So 17, not old enough. 18 is old enough. And we input a value for how many kilometers, and we get a result. So one question you might have now is, that's 2 branches, but what if we want any number of branches? Maybe there's a whole bunch of different paths we could take from one choice, or maybe a few different choices. And that's where the else if statement comes in, which is written ELIF in Python. And this is another statement we can add to our if statement that allows us to try even more branches. And it works very similar to what we saw, except each branch is going to have its own condition, except the last one, which is sort of like the default or the failsafe. And the syntax is going to look something like this. So we have that if part that we saw before. It works the same. So if condition 1, if that's true, we're going to run the block of code that says run this block of code if condition 1 is true. And then after we run that block of code, we're going to start again after the if statement. Then only if condition 1 is false, we're going to check the first else if statement, which in this case is going to be condition 2. If condition 2 is true, we're going to run that block of code under condition 2. And we could have any number of these else if statements we want. We could have 0 to how many ever we could fit in our Python code file. And each time that else if statement is only going to be evaluated if every one before it was false. So it's sort of like a waterfall falling down, and at each level there's a different condition to check. So for example, we could have any number all the way up to condition n. If condition n is true, we're going to run that last else if block. Otherwise, if all of the conditions that came before it are false, every single one, then and only then we can run that else statement. So that's a little bit confusing, so maybe we could try out an example. And what we want to create here is a program that's going to tell us an effect of several different Richter scale outputs or values. So the Richter scale is a scale that's used to measure sort of like the damage or the potential damage from an earthquake. We have a table here that shows those different potential damages. So a value of 8 or greater, most structures fail. 7 to 7.99999, many buildings destroyed. 6 to 6.999, many buildings collapse, are considered damaged, some collapse. 4.5 to 5.9999, damage to poorly constructed buildings. And less than 4.5, no destruction of buildings. So what we want to do is write a program where the user inputs the Richter scale value, and then it outputs the effect. If we were to make a flowchart of this, it would look something like this, where we have, at first, we're going to check if it's greater than 8. If it is, most structures fail. If that's false, then we're going to do the next check. Is it greater than 7? Then we do the next check if that's false. Is it greater than 6? And if that's false, then we do the next check. Is it greater than 4.5? And if all of that's false, then we are simply going to put out the case for if it's less than 4.5, which is no destruction of buildings. So let's explore how we could do this in Python. And I have the program written up here, but we're going to go try it out in PyCharm. So the first line, we are going to be taking input from the user to get that Richter scale value. And the interesting part is this set of ifs here. So the first one, if Richter is greater than 8, that means it's going to check if the value is greater than 8. And if this is true, we're going to run this statement, most structures fail, and then we're going to run down to the bottom. To make this a bit clear when we're testing it, I'm going to add an extra line at the end that says end. So what happens is after this is run, if it's greater than 8, we don't check or run any of these other parts of the if statement. We instead jump all the way back down to the first line after the if statement. If this is false, then we're going to jump and check if Richter is greater than 7. If that's false, we then check the next one and so on until either one of these is true and we run its code block, or we eventually get to the else and then run that. So let's put a breakpoint right at the beginning and run it in debug mode. Okay. We're going to step over so we actually get some input. And let's start with the one at the very end. Let's say we only have a value of 2. Okay. So we can see we have a value of 2, Richter equals 2. And right now it is checking, is Richter greater than equal to 8? We'll step over. And what happened here is this was false. So it jumped to the next else if statement. It didn't actually run most structures fail. We can still see in the console there's no output. So now it's evaluating Richter greater than 7. That's going to be false. So we jump to the next one. Now it's going to check, is Richter greater than equal to 6? It's still 2, so that's not going to be true. So we jump to the next one. And in this case, 2 is still not greater than equal to 4.5. So then we jump to the else. And in this case, else is always run if everything before it is false. So if each one of these statements is false, then we run else. And you can see that we get no destruction of buildings. And if we run that last line, we get end. So after the if statement, it jumps to end. So let's try that with a different value. Debug again. Okay, this time let's try giving it a value of 6. So Richter's equal to 6 now. We're checking if Richter's greater than equal to 8. It's not, so we're going to jump over that. We're going to check, is Richter greater than equal to 7? It's not. And now this one is Richter greater than equal to 6. We can see it's currently equal to 6. So 6 is greater than equal to 6. Since it's greater than equals, this means that's going to be true. And we are going to print out this line here. So you can see it jumps down to line 13 because that's the code block inside of Richter. And it's going to output many buildings considered damage, some collapse. And we can see that in the console. And you'll notice also what just happened. After we just ran this code block here, it now jumps out of the if and to the print end. You can even see it say end here. Because once again, it doesn't run all of these or check all of these. It only checks them if the ones before it were false. Since this one was true, it runs this and then it exits the if statement. This is never evaluated because the one before it was true. So we can try again and give it a really large value and see that it won't even consider any of this. It'll just try the first one. Let's give it some crazy value. Say 100, which probably isn't a real Richter scale value, but it should still work with our code. So we're going to check Richter greater than equal to 8. You can see our current value of Richter is 100. So that should be greater than 8. So right away, it goes right into the if statement. It's going to print most structures fail. See that in the console. And then it jumps right out of if to the last line to print end. So it's important to understand how these if constructs work because they are quite powerful. It allows us to explore many different branches in our code and make many different choices. Okay, let's switch back to the slides. And we are back. One last example of else if before we move on to something else. In this case, we want to try to use an if statement to do some error checking. So far, we've just been assuming that all user input is going to be valid, but that's not how things work in real life. The user could put in something silly. So the if statement allows us to do some simple error checking. So in this case, we want to write a program that takes the average of 3 grades input by the user. But we want to add error checking to ensure that those grades are sensible, that they're like a percentage between 0 and 100 inclusive. We want to output an error if any of the grades in this program are not in that range. So I have the solution here, but again, we're going to switch back to PyCharm and try it out. Okay, we're in PyCharm and we're going to have a look. So the first part here should be fairly straightforward to you at this point. We're just asking for 3 grades between 0 and 100. That's going to be output to the screen. And then we're actually inputting the grades. We're going to turn them into floating point numbers because grades could have like 10.22 or hopefully a better grade like maybe 80.99. Then here is the error checking. So we're going to check if each grade is valid. So this statement's going to check if grade 1 is valid. So it's going to check if grade 2 is valid. And this one's going to check if grade 3 is valid. If any of these are invalid, it's going to output the grade 1 is invalid, or grade 2 is invalid, or grade 3 is invalid, and so on. If all of these are false, which would be a good thing, because if all of these are false, it means we didn't trigger any of the invalid cases, then we're only going to do the average calculation. So all the grades have to be valid before we actually try to do the meat of this program, which is calculating the average. Average shouldn't be too surprising. It's just adding the grades together, taking the sum of the grades, and then it is dividing them by 3, and then rounding them to 2 decimal points to help us avoid any floating point errors. And then we output what the average is. So we can run this and see how it works. So let's try it with some valid grades, maybe a 75, an 80, and a 45. They didn't do so good on that one. We can see your average is 66.67. So let's take a look at how these if statements work. So the first one here is saying grade 1 is less than 0 or grade 1 is greater than 100. If either of these conditions are true, it means we're outside of the range. In this case, it would be a negative number. In this case, it would be a number over 100. So if either of those are true, remember OR returns true if either side is true or both sides are true, then we get an error. Print grade 1 is invalid. And that also means we don't run this code here because that's under the else. So as soon as one of these is triggered, we don't trigger the else. The grade 2 and grade 3 checks are exactly the same. We're just using a different variable. In this case, all of these grades are valid. So this was false, 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 and this was false. So then we ran else, and it actually did the calculation. Let's see what happens if we put an invalid grade. So we'll start off with grade 1 being invalid. We'll say -10, and we'll make the other ones valid. See, we get an error that says grade 1 is invalid because this part here was triggered. It was this part here was triggered. Grade 1 less than 0. So that means -10 is less than 0, which is true. So this was true. Grade 1 greater than 100 would be false. So we got true or false, which meant that this evaluates to true. And we print error, grade 1 is invalid. And then we jump to the end of the if statement, which would be down here, and there's no more lines, so the program ends. Let's try with a different grade being invalid. So we can say 75, and here we'll say 999, which is an invalid grade, and 40. And as expected, we get grade 2 is invalid. And we could try it for the last one. Again, like I said before, we should always test our program for all the different possible branches. I'll make this one -1. And we get grade 3 is invalid. So it seems to be working correctly, though there is one special case that debatable if this handles correctly. And that is, what if all the grades are invalid? Like if we had -1, -2, and -3. Well, the way we have this written correct right now means that only the first one is going to be triggered. Because we detect that grade 1 is less than 0, this is true, this is false, so it evaluates to true. That means we run this line. But because this line was true, it means we don't check any of these other statements. We don't check this else statement, we don't check this one. We just run this line, and then we jump to the end of the program. That's why we didn't get error grade 2 is invalid, or error grade 3 is invalid. So if we wanted to get an error for each run that's wrong, and only do the average if they're correct, we'd have to restructure this code somewhat. Okay, the last topic we're going to cover in this video is nested statements, particularly nested if statements. And you remember there is that little bit of a code block under an if statement that's run if the if statement is true. Well, that block of code can contain other if statements, and then that block of code can contain other if statements, and so on all the way down. And this allows our program to have far more complex branching and be far more powerful, allows us to solve many different kinds of problems. And this will probably be best demonstrated with an example. So we want to write a program that follows this example here, which is write a program that asks the user to input their drink order. If it's an alcoholic drink, we want to ask the user for their ID. If they're under 19, we want to reject the order and print out something saying like, you're too young. If they're older than 19, or the drink is not alcoholic, then we want to serve them their drink. In this case, we'll just say it's printing out, here's your drink, or something like that. Okay, here we have the flowchart for this problem. Remember, the flowchart sort of lays out a general algorithm, how to solve a problem, that we can then use to write code to solve it. So we're going to start at start, and then we're going to head down here. And this is where we ask the user for their drink order. In Python, that's probably just going to be asking for an input of what they're selecting from the menu. Then we're going to head down here if the drink is alcoholic. So if it's an alcoholic drink, then we are going to want to follow the true path. If it is not an alcoholic drink, then it's a very simple case. We'll go down false, and we just serve them their non-alcoholic drink, and we're done. So if it is an alcoholic drink, then we want to check their ID. And after we get their age, we then want to check, are they under 19? And you can see here, this is why it's a nested if statement. There's a decision, and then only if decision is true, we then make another decision. So there's a decision inside of another decision. So this isn't a bunch of alternatives. This is a second decision within the outcome of another decision. So if they're under 19, then we want to reject their order because they're too young for a drink. And then we go back down here to the end. If they are 19 or over, then we are going to serve them their alcoholic drink, and we head back down to the end of our program. So how can we capture this in our actual code? Okay, here we have an implementation of this algorithm in Python. And this does look a bit confusing, but we'll go through and break it down a bit. But one of the first things we should address is the different levels of indentation found here. So you can see here that there is the indentations that we're used to from if statements, but we also now have a second level of indentation shown here with those blue arrows. Or we can sort of draw each level here. So we have level 1, which is sort of the default level where everything's lined up right against the edge of the file. Level 2 for that first if statement, like if order equals 1 or order equals 3. And this is going to be everything inside that block. And then level 3 is for the nested if statement. So every time we go down another level, a nested if inside of an if, we need to increase the indentation level because Python needs to still know which blocks of code are in which if statements. So this might be a little bit clearer if we draw sort of boxes around them. So the red boxes are for the code blocks that are for that if statement. So this first big red box here is for the order equals 1 or order equals 3. If that's true, the first big red box is going to be executed. If that's false, we then check the else if, which is order equals 2 or order equals 4. If that's true, then we run the second red box. If both are false, then we run the else, which is the third red box. Now, inside of the first red box, which is our first block of code, that's going to be run if order equals 1 or order equals 3. Then we have a second block of code because there's that second if statement. We have that if statement that's checking their age, if age is less than 19. And then we have 2 code blocks inside of that. So whenever we're starting a new block of code, we're nesting something inside of something else, we need to increase the indentation level. So I can't stress enough that this indentation is important in Python. It's not optional. If you don't do it correctly, your program will either just give you a syntax error or it will have some odd results that won't be what you expected. So always keep track of where things should be indented. Okay, so there's also this weird print statement at the top. It looks confusing, but all it's doing is just printing a string. There is something new that we haven't seen before here yet in a video, and that is we have a string that's broken up on 2 lines. So sometimes a string starts getting way too long and it's like going way off the side of your editor. And one way we can avoid that and make our code look a bit more beautiful is then restarting that string on the next line. So if we have a second string directly underneath another string with nothing in between them, like no addition, no operator, nothing else, then it counts that as one string. So Python puts this together as one string. And then that's passed as a parameter into the print function, and it outputs it to the screen. Now, the other thing here are those escape sequences, the /ns. If you recall from our previous video, those mean line breaks. So this is one complex line that's going to print multiple lines of output, and it's going to look something like this. So it's going to basically print out the drink menu. So it's going to print drink menu, then there's a line break, the first /n, then there's going to be a whole bunch of dashes, then another line break, then the first option, which is wine, then a line break, the second option, which is Pepsi, a line break, the third option, which is beer, a line break, and the fourth option, which is water. So all that line does is print out that menu. After that, we're simply taking in their order. Nothing really special here. I do have a line break in it just to give us a little bit extra space. Let's now trace through this code, assuming the user input an order of 2, which means that they're ordering a Pepsi, a non-alcoholic drink. So we arrive at this first part of the if statement, and the condition is order equals 1 or order equals 3. So order is currently equal to 2, so both of these are false, and that means we do not enter this part of the if statement. Instead, we jump down here to the next else if. The condition for this else if is order equals 2 or order equals 4. Order does equal 2, so that's going to be true. And that means we enter this block of code, which is simply going to be printing out, here is your non-alcoholic drink order. And we can see that's been printed to the output window. So let's try this again, but with a different value. Once again, we print out the menu. We ask the user for their input. In this case, they're going to input a 1 for wine, which is an alcoholic beverage. We get to the start of the if statement, and we check, is order equal to 1? And it is in this case, so we get a true value. That means we're going to enter this code block. So the first line is age equals int input age found on ID. So we're getting input from the user, and we're going to turn that into an integer value. Let's pretend that they input 20, so that means they're an adult. The next line is checking, is age less than 19? So 20 is not less than 19, so this would be false. So that means we don't enter this block. Instead, we jump to the else, which is printing, here's your alcoholic drink. So what's really important here is to remember, or at least to understand, which else is connected to which if. This else is indented once, so that means it's part of the inner if, whereas the else on the outside to print invalid order is not indented at all, so that means it's connected to the outside if. Being able to understand which part is connected to which and which indentation level you're at is critical for being able to understand these if statements. If age had been less than 19, instead of jumping into the else, we would print out alcoholic drinks are only available for customers 19 or over. The other possible case here would be if the order is invalid. So that means it's not 1, 3, 2, or 4. In that case, the outer else would be triggered and we get invalid order, try again later. That's all I have for you in this video. I highly recommend trying out some of these examples to try to get your head around if statements. They can be a bit tricky if you're new to programming, so it is important to actually try things out in PyCharm. The best way to learn programming is through practice rather than memorization, so it is important that you're actually trying out these examples and tinkering around with them a little bit, changing values, running them for different inputs, and seeing how things work. Thank you for watching, and have a great day.